Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. Today, date is 8/16/24, and this is physics lesson number 22. And I'm going to introduce you what is a uniform motion. Just like the name suggests, uniform motion is when you're going from point A to point B and in a straight line. Okay. So in this particular section, we're going to discuss motion only in two dimensionals. Okay. Going from, let's say, point A to point B. Okay. That is your uniform motion. Now, in terms of physics, we can elaborate that on uniform motion more than just it sounds like. That motion. Oh, what is a motion? Motion is you're moving from point A to point B. Sure, that's fine, that is motion. But however, but conceptually, when you bisect uniform motion in terms of physics, then you'll be surprised that there are so many sub elements to that. So I'm going to try to explain you those today. So let's go ahead and get started. uh, like I said, we're going to discuss motion only in one dimension. Okay, so I'm going to draw this again, just like in my last lecture, because I want to make sure that the concept is crystal clear. Okay. So I'm drawing a position graph. Let's say X is in meters. Okay. And this is T, which is in seconds. All right. And then this right here is the position line right here. I'll draw that in red as straight as I can. All right. So this is my position. Pretend that this is straight line. Okay. So if I do some tick marks right here, let's say 1, 2, 3, 4, 1 second, 2 second, 3 second, 4 second, and then 1 meter, 2 meter, 3 meter, 4 meter, right? Okay. So that is what my position graph is. Okay. So at every second, my distance is changing. At 2 seconds, it's 2 meters, 3 seconds, 3 meter, and so forth. All right. Now, what if I take a derivative of that? Okay. So if I take derivative of that, and I've told you in my last lecture, derivative of distance is velocity. Okay. So then this right here, time is in second, and this is my velocity in meters per second. Okay, if I want to draw this in a graphical manner, what should it be? As you know, that in my last lecture, when we took slope, rise over run at different points, point A, point B, point C, point D, all right, I'm going to put this point A, point B, point C, point D. At every point, the slope was constant. It was same. So then, if you want to show that derivative of distance in velocity, it's a constant. So I can draw this line right here. So that is my velocity, which is constant. I'm taking derivative of this and I get this graph. Now, as you guys already know, derivative of velocity is acceleration. So let's go ahead and draw a graph for acceleration. So I'm going like this, okay? Time in second. And then I've got acceleration in meters per second square. Okay, now let me ask you this. What is the graph going to be for this? Derivative of distance graph is this. Okay, it's a constant line because the slope is not changing. Any slope anywhere along this line is going to be same. Even if you go 100 miles away, your slope is still going to be same. So now, what is the derivative of a constant? Calculus lovers, question for you. Derivative of a constant is 0. Okay, so then my graph is going to be like this, right? This is it, the one in red. It's over x-axis, it's 0. Why is it 0? Because there is no rate of change. your velocity is constant. You go on let's say you go on 20 miles per second constantly. You're not increasing speed or decreasing speed, and acceleration is not changing. Acceleration happens when you put your foot on the gas, boom, increase your speed. But nothing like that is happening in there. And what is derivative? What is slope? Rate of change. So there is no rate of change in this case. That is the reason acceleration is zero. Okay, hope that's clear. Now I'm going to introduce you with the formula which is used in uniform motion. Okay, and that formula, let me write this down right here: equation of uniform motion. Okay, now in your books it might show, uh, let's say x0 is your initial point. That's where you are right now. I'm right here. This is my initial point. In some books, they will also show this as xi, so don't get confused. Okay. And then the formula for that is basically x is equal to, let me write this down first, then I'll explain you, x0 plus v0 times t. V0 is basically your initial velocity. Okay, so initial velocity is right now, I'm standing right here, I'm not moving. What is my initial velocity? My initial velocity is zero. If I'm moving 1 second, 2 second, 3 second, then you can say I'm moving at 3 seconds, I'm moving 5 meters per second, and so forth. So now this is the formula which is going to be extensively used by physics lovers to solve the numerical problems. Now, I remember when I was back in college, I don't even remember when, long time ago, a lot of students were saying, oh, yeah, I memorized that formula. I memorized it. I'm going to crank up. I'm going to go into the exam room and use this formula. Whatever is given, plug it in. Not the right approach. You have to understand conceptually what this formula means. Otherwise, your professor will give you a tricky question and you're bound to make a mistake. So I hope you follow me and understand the conceptual background of this formula. Okay. First of all, this right here, x is the final position. Okay. Final position, meaning if I have this marker going from point A, which is at 0 point, and I go up to 10 meter, 10 meter is my final position. Okay, so that is what what I mean by x. Okay, x0 right here is where I am standing right here. That's my initial position. So I'm going to write this down as initial position. Okay, and then what is v naught? V naught is my initial velocity. Okay, initial velocity. Okay, so let's say at time zero, I'm going 5 meters per second. That is going to be my initial velocity. Maybe if I'm resting, I'm not doing anything, then my initial velocity is 0 meters per second. Okay, so understand the concept. When I say at time zero, it doesn't mean that clock is zero. It means basically when you started looking at the speed, at that time I was moving 5 meters per second or 10 meters per second. So understand that concept. A lot of students miss on that, and they conceptually think at time zero you should be at rest, not moving. Not true. When we start looking at the problem, the professor says at time zero, in other words, when we started looking at this car, it was already moving 5 meters per second. That's the concept which you need to understand. Okay, so x is equal to x0 plus v naught t. And what is velocity? let's just look at this section. Velocity is meters per second, all right, multiplied by time. And time is also in seconds. Okay. So this second cancel, and then your answer is in m, which is equal to meters. Okay. So I just wanted to go over this concept of this formula right here. I want you to understand the formula. If you want to listen to this lecture twice, do that. But understand why we have this formula and what's the background, what's the conceptually theory behind this. Then you will not make a mistake on your physics numerical problems. Thank you so much for watching. Stick with me. Next lecture, I'm going to solve some problems. Take care of yourself. Till next time. Bye-bye.